Okay, we're on to similar triangles. Right, now, first of all, let's recognise if they are similar triangles. Okay, now then, if you think about this question 1 here, this smaller one, kind of just looks like a smaller version of this bigger one, doesn't it? It looks very similar. Oh, there's the word similar. Same shape, yes, they're both triangles, alright? But they are similar. One's just a bigger version of the other, or one's a smaller version of the other, okay? Look at question 2. Well, if you look at the big one on the left, it looks like if you shrink it and just flip it, it becomes a similar one to the one on the right. They're similar triangles. But in 3, it's like hard really to see really. I mean, they're not similar triangles. They've got, I keep wanting to say different shapes. They're both triangles, of course. But, yeah, they are not similar triangles. So sometimes it's just recognising which is a similar triangle. So, let's have a look. Here's 2 similar triangles. Now, okay, so the vertical of the big one is 20. The vertical of the little one is 12. But because they're similar triangles, they have a similar ratio, okay? In other words, this one might be the big one might be twice the size of the little one. So all the sides of the little one will be half the big one, okay? Everything will kind of go the same kind of ratio, similar triangles. I'll just show you this then. Okay, so if this is 20 on the big one, this is 12 on the little one, if I half, suppose that's 10. If that's half, okay, the base here is half that one, then this here must be equivalently, must be 6. Okay, it's half that 12. And I'll show you. So, the 12, this is the vertical on the little one, alright, over 20, which is the vertical on the big one, okay. Should match, okay, here we go. So, I'm doing the little triangle numbers on top. So, 6 is the base of the little one. 10 is the base of the big one. Okay, so they should match, and they do. And think about it, they're equivalent triangles. If you want to do this, because you're going to have to do this definitely soon, remember cross multiplication? 12 times 10, 120. But also, what's 20 times 6? That's 120. Okay, that's just showing that it's true. Okay, so there you go. I've just want to prove in some ways that they're similar triangles, or at least if I know that some numbers, I can fill in the missing numbers because they're similar triangles. So let's get an eraser on this. Now supposing, I'm just going to change these numbers on the base. Alright, supposing, let's get rid of this. Supposing that's 15, alright? But I don't know what that is. It's got to be kind of equivalent, alright? But I don't know what it is yet. I've got to kind of work it out. So again, 12 is the vertical of the little triangle. 20 is the vertical of the big triangle. Now I'm writing the little triangle numbers on top. So x is the base of the little triangle. 15 is the base of the big triangle. Alright? So how do I find x? Right, well, think about that cross multiplication. 12 times 15, I believe, is 180. Now the other way, 20 times x, all I can write is 20x. Okay, that's all I can write. 20 times x is 20x. Now some of you might know this, that to get to this x by itself, okay, it's got a 20 next to it, you divide by the number next to the letter. It's like saying 20 over 20, kind of cancelled, it's actually 1, alright? But don't forget to do the same to this side as well, okay? So what's 180 over 20? It's 9. So this x must be 9. So I'll erase this and write 9. Okay, there you go. I've just found the base of that little triangle because these are similar triangles. Okay, let's try it one more time. How about if I know that this, okay, let's suppose I know, think about this is 16, okay? Supposing I know that that is 16, the diagonal of the little triangle. Alright, so what's the diagonal of the big triangle? Now, I'll use the base numbers now, okay? I've got that, they're filled in. Instead of using 12 and 20, I'll use 9 and 15. So, here we go. 9 is the base of the little triangle. 15 is the base of the big triangle. 16 is the diagonal of the little triangle, but I don't know what the diagonal of the big triangle is, okay? So that's how I'm laying it out, okay? Little triangle on top, big triangle numbers on bottom. So, here we go. What is 15 times 16? It is 240, okay? what is 9 times x? All I can write is 9x. I then divide by the number next to the letter. Okay, can I say it's cancelled? And I think, I did this earlier, I think you get 26.66666 or 26.7 to the nearest tenth. Okay, so that's what that would be. And that's how you do similar triangles. I'll show you a good application in the next video.